Because from yes, let's start from here. Okay, equal mass of two different liquids are put into the identical beakers. They are heated from 20 to 30 degrees centigrade by the heater of the same power. Liquid 2 takes twice long as to heat as liquid 1. So this is your liquid 1, it takes t time, and this is liquid 2, it takes 2t time. Okay, is this clear? So which statement is correct about that? Both liquids are receiving same amount of energy. This is very important point, because energy is equals to power into time. So from this one you have to analyze this part. I will come back to that. Liquid 1 receives more energy than liquid 2. This is again solved from this equation. Then thermal capacity of liquid 1 is equal to the thermal capacity of liquid 2, right? This is depending upon the nature of that material, and thermal capacity of liquid 1 is less than that of thermal capacity of liquid 2. Okay, so I believe that you people got the answer. So which would be the right answer according to your opinion? Then I will explain this all. Yes, Meera, what do you think? I will show you the
Uh,
question.
yeah, so show
Yes.
me the question, Ignite. Sir, C.
Okay. So yeah. What do you think?
Yeah. Can you go up? Sure.
Yes. This is that question. Okay, hurry up. Continue. Yes.
Yeah.
Okay, me. Sorry. Yes. Yeah. Starter is not good. You people are trapped. Okay, now let's discuss that. Mira, check this one out. That if the heat capacity of both the liquids is same, then both would have same temperature rise and in same time. So this is that formula. Here I will use pt is equals to mc delta t. Change in temperature is same for both. Mass of the liquid is same. Here it is said that liquid, yeah, equal masses, so it means mass does not have any impact, right? Power of the heater is same. It is mentioned anywhere by the heaters of the same power, so it is same. So time is only dependent upon what? Specific heat capacity. Okay,
Yeah.
so if if liquid 2 is taking double time, so it means its specific capacity is also double. Okay, got it? So
Yes.
specific heat capacity or thermal capacity of liquid 1 is less than that of the thermal capacity of liquid 2. This is basically uh, mean very simple to understand that if that substance will have less heat capacity, then it would take less time. I was talking about these 2 points, which are basically confusing points. Both liquid receive same amount of heat. Why did you not opt this question, this answer, or this option? Yeah.
Yeah.
Um,
Yes,
uh,
sir.
it is mentioned that they have same power. So
Okay.
should they have same
Yes, same amount
energy
of
transfer?
energy. Yes.
ओके, मेरा व्हाट्स योर ओपिनियन अबाउट दैट? आप क्या कहती हो?
सर आपका क्वेश्चन क्या है?
मेरा क्वेश्चन ये है कि इसने बोला हुआ है कि बोथ आर हैविंग सेम पावर, राइट? हीटर्स
जी.
आर सेम पावर, लेकिन उसने साथ में ये बोला हुआ है कि both the liquids are receiving same amount of energy. So is it true?
Yes, sir. It mentioned in the question.
So why did you not opt option A? Okay, yeah, and Mira both. देखो, this is our trap. Remember this thing. This is a very, delicious trap. If power is same, I have written this equation over here that energy is not only power. Energy is power times T. So for liquid A, for liquid one, your power is same. Let's say it is power P is equal to power is equal, sorry, energy is equal to P into T. But for liquid two, this energy is equals to P into 2T. तो अब मुझे ये बताइए कि this is energy for liquid 2, it is 2 pt, and energy for liquid 1, it is pt. So they are not receiving same amount of energy. Got it?
Yes.
So don't get trapped in these type of options. They do not get equal amount of energy. Equal energy. Got it? Is it clear? So this would be the right option then. Should I move forward? ये बात समझ आई?
Yes.
Yes.
Yes. Okay. अब आते हैं. There is another question for you. A knife is being sharpened on a rotator spinning stone. It's just a machine to sharpen the knife. A spark flies off and lands on an operator's hand. The spark is very hot. Very small piece of metal. The operator feels nothing. What does this show about the piece of metal? It has very high thermal capacity, it has very low thermal capacity, it is good conductor of heat, it is poor conductor of heat.
सर
Mhm.
से ये थर्मल कैपेसिटी को एक बार आप दोबारा से डिफाइन करेंगे?
Yes, thermal capacity is basically not specific heat capacity. Remember this thing. Thermal capacity is mass times specific heat capacity. Actually, thermal capacity is your heat capacity, right? Thermal capacity क्या होती है आपकी? Heat capacity. So in your syllabus it is named as thermal capacity. ठीक है? इसको हम लोग क्या कहते हैं? Thermal capacity. So thermal capacity is the amount of heat required to raise the temperature of any mass, or amount of heat which is required to change the temperature of any substance. ठीक है? बात
Yes.
समझ आई? Okay. Now, what about this question? Yes, come across this question. What's your choice? What you people will uh, answer this question? That it is very. I mean, I have selected those questions which are really tricky questions, so that I have to address them. So that piece of metal flies from that blade to the hand of that person. So he feels nothing. There is one reason behind that, right?
Poor
The
conductor of heat.
poor conductor of heat.
It passes slowly.
Yes, Meera, what's your idea? Oh,
Sir, maybe it has low thermal capacity.
Oh
it
yeah,
has
yeah,
yes, it has low thermal capacity, right?
yeah.
The metals have very low thermal capacity. That's why their temperature is decreased rapidly. That's why that person is not feeling some heat at the hands. Got it?
Yes, sir.
Is it clear? Yeah, yeah.
Yes, clear. No problem.
Good. Okay, now come to this question. This is another. Oh, I was not to reveal the option, but I did. Four blocks made up of different materials are each given the same quantity of internal uh, energy, or heat energy, right? The option is which block has the greatest thermal capacity. So which block has the greatest thermal capacity? Here the important things are four blocks made up of different materials. They are not having the same material, are given the same quantity of heat. So you will write Q equals mc delta T, right? Which block has the greatest thermal capacity? So it means we are talking about M into C together, right? Which block has this factor highest? Okay, so it is same, right? So that block in which in which temperature rise is largest, okay, that will have the lowest heat capacity, and that block in which temperature has increased very small or by a small rate, that has very large heat capacity, isn't it?
Yes.
There you go. So here temperature is 2 degrees centigrade, 4 degrees centigrade, 6 and 8. It means it has the lowest heat capacity, you know. Its second number, it is third, and it is fourth, right? So it is the lowest, then bigger, then bigger, and then. So it has the largest heat capacity. That's why its temperature is just raised by 2 degrees centigrade. So is this
Other
clear?
mass also.
Yes, yeah, yeah.
Other mass also affects helium. Like,
No, mass is not mentioned here, but the word thermal capacity includes mass. Okay,
okay.
so thermal capacity. So it means that here, if I say that it is MC is equals to thermal capacity, right? Thermal capacity, then definitely that temperature in which uh, temperature rise would be more, that would have more thermal capacity. Mass times its specific heat. Okay?
Okay.
Okay. So again, we have the same type of questions. I think it would be repetition. So will you be able to address these type of questions? I will send you this worksheet as well. So should I move to the to my next topic, which is basically melting and boiling? Hanji, Meerup, yeah, yeah.
जी सर.
Latent heat. Okay, okay. So actually, now what topic we are going to discuss today, that is melting and solidification, boiling and condensation, means state change. Actually, the name of the topic is state change. So when we talk about this, that what state change means, uh, substance is either solid. If it is solid, it is converting itself to liquid by the amount of energy absorbed. Then from liquid, it can be converted to a gas, or vice versa. So this is basically called state change. So first is boiling and sorry, melting and boiling. These are two state changes. So first I have to talk that what is melting, boiling, and evaporation are, how these three things are different. When the objects are converted from solid to liquid, this is called your melting, and then it is reversed, it is called freezing. And when the objects are basically evaporated or boiled, it is called boiling or evaporation. I will tell you about the difference. What is the difference between evaporation and boiling? They are converting from liquid to gas, and then when they are converting back from gas to liquid, that is called condensation. In this process, energy is added, and in this process energy is released. So I told you this thing, that when you are going to release the energy, gas would be converted to liquid and liquid would be solidified. But when you are going to add the energy, solid will be liquid converted to liquid and liquid will be converted to gas. So this is basically mentioned over here. That's why I have no need to write on that. Then we have melting. It is the process by which energy is supplied to the changes the substance from solid state to the liquid. That takes place at a specific point, which is called melting point. All the pure substances have the melting point at a specific temperature. When we reverse that process, freezing takes place, and the freezing and melting points are always equal. Okay, I mean, ice melts at 0 degrees centigrade, right? And liquid freezes at, I mean, water freezes at 0 degrees centigrade. So this is actually what we usually do for the liquids. Then boiling and condensation are reverse process for each other. As you know, that boiling is actually where when the energy is being supplied to the system, that makes I mean, that changes the substance from liquid to the gas. And if we release the heat, the reverse of this process takes place, and liquid is converted back to the gas is converted back to the liquid. That is called condensation. So condensation and boiling are actually the same points, okay, for one substance. Then we have boiling and evaporation. Yes, this is very important topic because so many questions are asked from that one. In boiling and evaporation, you have to remember that boiling takes place in only at a specific temperature, right? Boiling and evaporation involves the change in state from liquid to gas. This is the similarity between these two, that in both of them what happens, liquid to gases, state is changed from liquid to gas. There are, a liquid boils at a definite temperature called boiling point, whereas evaporation occurs at all temperatures. This is the first difference, right? This is the difference, that boiling takes place at boiling point and evaporation takes place at all temperatures. And evaporation takes place only from the exposed surface. I mean, evaporation takes place only at surface, whereas boiling takes place throughout the liquid. Okay, will you be able to remember these points?
Yes, sir.
ठीक है, yeah, will you be able to do?
Yes.
ठीक है. Okay, next is, basically here is an activity between boiling and evaporation. It is a visual concept delivered to you, that in boiling these bubbles are formed and the steam is obtained, but in evaporation only small amount of steam is being obtained, no bubbles are being seen. So evaporation is taking place only at the surface. So from the surface, highly energetic molecules leave the surface, but boiling, mm, the molecules are coming from the surface from the heat source and then they are leaving the surface. So that is the major difference between evaporation and boiling. Okay, then we have some factors affecting boil evaporation right here, because this is the topic, so I'm going to write those factors affecting boiling. Factors affecting boiling, oh sorry, evaporation. What are the factors? Do you know? Any one of you? Yes? Surface area. Okay? That's why we basically spread the cloths to dry them up. So, surface area. So, when more will be surface area, more will be evaporation. Right? Surface area would be greater, then evaporation rate would be greater. Will it be clear? I mean, I have written in this way, or should I write in proper words?
No, sir, it's fine like this.
Okay. Secondly, surface temperature. ठीक है? Yeah. Surface temperature. If you place uh, a hot cup of tea or a cup of hot tea nowadays in your room, you will observe more evaporation. But if that would be cold enough, evaporation will not be observed. So again, surface temperature would be more, then evaporation rate will be more. Third is density of the liquid. I mean, nature of the liquid, which is basically called viscosity. Nature of liquid. So in nature of liquids, viscous liquids have less evaporation, like honey, diesel. So they are viscous liquids. So viscous liquids have less evaporation because they have strong intermolecular forces. Okay, because of strong intermolecular forces. Because of strong intermolecular forces. Okay, is it clear? And the last is drought or humidity. Okay, humidity. This is also a factor. So when you are in an environment just like nowadays, cold weather, drought is more, so evaporation increases in that. Evaporation increases in the drought, where in humid environment evaporation decreases. Got it? Because already there are so many vapors in the atmosphere. So in humid environment, evaporation decreases. That's why in your uh, humid season like monsoon or June, July, August, there are the skins become oily and evaporation is not taking place, and we are facing that problem. But in winter, we are facing the problem of getting dryness. So these are basically the concepts of evaporation. I hope that it would be clear to you. Is it clear?
Yes, sir.
Yeah. Okay. Yeah, yeah. Is it clear to you as well?
Yes.
Okay. The next is latent heat. This is the major topic again. Latent heat is basically the heat required to change the temperature. What is latent heat? The heat required to change the sorry, sorry. I'm going to reframe my words. The heat required to change the state of the substance. Right? The heat released or absorbed at constant temperature during the change of state is known as latent heat. So there are two types of state changes. One is between solid and liquid, and one is between liquid and gas. So that's why there would be two latent heats. One latent heat is called your latent heat of vaporization, and the other latent heat is called your latent heat of fusion. Okay, so here I will talk about the latent heat and specific latent heat.
सर एक मिनट ऊपर कीजिएगा.
Mhm.
Just a minute.
Okay. Okay.
Yes, sir.
So we will talk about these 2 points: latent heat of fusion and latent heat of vaporization. But before that, I will talk about the difference between latent heat and specific latent heat. So latent heat of fusion is the energy needed to change the substance from solid to liquid without change in its temperature. This is mandatory part of your writing. So what is the latent heat of fusion? That is the energy needed to change the substance from solid to liquid without change in its temperature. Okay, and then we have this. Um,
सर पहले हम इसके डिफरेंसेस ना कर लें लेटेंट हीट और स्पेसिफिक लेटेंट हीट के.
Sorry, क्या कर ले?
सर differences between latent heat and
हाँ,
specific latent heat.
लेटेंट हीट एंड स्पेसिफिक लेटेंट हीट में यही फर्क होता है. जैसे आपका हीट कैपेसिटी एंड स्पेसिफिक हीट कैपेसिटी में लेटेंट हीट is heat required for any mass. Heat required for any mass. ठीक है. और स्पेसिफिक हीट है heat required for 1 kg. Heat required
Okay, sir.
for 1 kg. ठीक है. So for 1 kg mass, whatever the heat you will require to change the state, it is specific latent heat, and latent heat is the amount of heat to change state of any mass. So we will talk about specific heats. These are the specific latent heat of fusion, and this is the specific latent heat of vaporization, right? This no, wait. It is sorry, it is not for 1 kg. Is it written anywhere? No, it is not. It is latent heat. So it is your latent heat. So actually difference is हम लोग कर रहे थे. This is latent heat. Latent heat of fusion is the energy needed to change the substance, any substance. No need of mass over here. ठीक है? And latent heat of vaporization is the energy needed to change the substance from liquid to gas without changing temperature. इसको हम लोग क्या कहते हैं? This that is called your latent heat of fusion and latent heat of vaporization. Now the latent heat or energy needed to change the substance from solid to liquid or liquid to gas depends upon the mass of the substance. This is very important concept. From here, enter in the specific heat specific latent heat. So this latent heat depends upon what? Mass. Got it? Is it clear? Latent heat किस पे डिपेंड करता है?
नीचे तो
Latent
जो
heat,
आपने पहले डिफरेंस लिखवाया था दोनों का वाज इट नॉट
no, no,
करेक्ट?
no, that was correct. But it is the same thing which is being written over here or being explained, but in two different steps. First, it is about your latent heat. ये जितना सारा लिखा हुआ है, this all is about your latent heat. Okay. Now we will talk about specific latent heat. मैं ये कह रहा हूँ.
ओके.
Okay. So specific latent heat is the amount of heat, right? It is basically written with LF, is amount of heat energy needed to
Sir, one
change.
question. There is
Yes,
latent heat of fusion and then there is latent heat of
vaporization.
vaporization. Okay.
ठीक है. Similarly, we have specific latent heat of fusion and we have specific latent heat of vaporization. So here, the specific latent heat of fusion of a substance is amount of energy needed to change unit mass. Really, really important point what I was talking about. For 1 kg, for a unit mass, what amount of heat required for 1 kg of the substance to change it from solid to liquid without changing its temperature. You have to recall this. Actually, this is memory recall. Exactly asked for 2 marks, right? So please recall it as it is for 2 marks. Okay, that is called your specific latent heat of fusion. Is this clear?
Yes, sir. Just let me write that down.
Okay,
A minute.
I will send you that. Don't worry. I will send you these notes. इससे पहले वाले मैंने आपको भेजे थे कि नहीं भेजे थे?
जी
नहीं
सर.
भेजे हैं? चलो ठीक है. अच्छा, अब now I have solid and I'm going to convert that. I'm going to give some heat to this, and now it is converted to the liquid. Now check this one. Its mass does not change. Check karo. Its mass is same. So that amount of heat which is required for that purpose, it is called its specific heat latent heat of fusion. Is it? Should I write down the formula? I will check that formula over here. I will write down formula anywhere here. Okay, let's say, as I told you that Q is equals to M. The heat which is required to change the state is directly proportional to mass. You have to melt more mass, you need more heat. So from this point, this Q is usually used as L, capital L, or simply we use it Q is equals to M times L, and we use a F over here for fusion. So I use this one. I recommend you this equation in this way, that QF specific latent, sorry, QF thermal energy required for fusion is equals to M times LF, where LF is your specific latent heat of fusion. LF is specific latent heat of fusion. Okay, and what will be its equation then? C is equals to QF divided by M. C is equals to QF divided by M. That's why its unit is joule per kg. What is its unit?
And sir, what is QF?
QF is the total heat required for fusion.
And M is mass, right?
Yes.
Okay.
QF is latent heat. You can simply say latent heat. And LF is specific latent heat. Specific latent heat. Okay, yeah, is it clear? Yeah. Are you there?
Yeah, it's clear now.
Okay, very good. Now I will talk about specific latent heat of vaporization. In specific latent heat of vaporization, as I told you, that specific latent heat of vaporization is LV, and is of a substance, or is the amount of energy needed to change a unit mass, again unit mass, of a substance from liquid to gas. This is very important point. And another important point is without changing its temperature, right? So that amount of heat energy required to change are required to boil 1 kg of water, sorry, 1 kg of liquid without changing its temperature is called latent heat of vaporization. Okay, so here I will use QV is equals to MLV. I will use this equation for the solution. Okay, so here again QV is latent heat of vaporization, latent heat of vaporization. Okay, Q, oh, sorry, LV is specific latent heat of vaporization, specific latent heat of vaporization. Okay, and then M is mass of substance, mass of substance. Is this clear? Is this clear to you?
Yes, sir.
Okay, yeah, yeah, clear to you as well. So
Yes,
Yes.
this is
somebody
to
recall.
memory recall. You have to memory recall this one as well as you have to recall this equation. Now let's talk about melting and
QV
boil.
equals to,
Sorry,
एक से मुझे बस QV वाला फॉर्मूला लिखना है.
लिखो लिखो लिखो, कोई मसला नहीं। तुम असल में मैंने सोए हुए जगह है तो अब तुम्हें टाइम तो देना पड़ेगा ना मेरे बेटे।
नहीं सर. ओके सर, थैंक यू.
डन। ओके,
यस सर.
नेक्स्ट पे आते हैं। नेक्स्ट इज देन मल्टिंग एंड बॉइलिंग कर्व। ठीक है, जिसको हम लोग क्या कहते हैं, मल्टिंग एंड बॉइलिंग कर्व है। तो मल्टिंग एंड बॉइलिंग कर्व is basically this thing. This is that. देखो, it's very, I mean, a beautiful explanation over here that this is the temperature on y-axis and time along x-axis. देखो, in first half, this is solid. You are going to heat up a solid, right? The kinetic energy of the particles increases and the particles move fast and temperature increases when it is heated. So you are going to heat a solid. Heating solid. Solid is solid. It is not being changed, but it is being heated. Next, here it is solid plus liquid. What does it mean? That the heat energy is absorbed to break the forces of attraction between the particles, and now the change in temperature is taking place. So here, some of the amount is liquid at initial stage, and sorry, solid, and then finally all is liquid. So latent heat of fusion is absorbed, and temperature is called melting point. So this is actually solid melting. Here it was solid was heated, and here in stage two, I am going to melt a solid. And here, check this one out. This arrow tells you that melting is begin, melting is started, and here melting is completed. So that's why I told you that these are 2 points. Here melting is started and here melting ended. Now your N- this all is your liquid. These are the groups. तो ये बात याद रखनी है कि this is your liquid. Okay. So when it is liquid, one more thing I wanted to add in this comprehensive chart, that here you will use Q is equals to MC delta T formula, or you can say Q is equals to MC delta theta for solid, right? For solid, you can find out the specific heat capacity of solid. Here, which equation will be used? Here you will use QF is equals to MLF because melting is taking place. So you will use that equation. Maybe he has used anywhere or not. No. Okay. Again, here your mm, liquid is heated. So when you are going to heat up a liquid, what do you use? You use Q is equals to mc delta T, yeah, mc delta theta. But this is that for liquid. This is for liquid. For example, I had ice at a starting point. So here I will use C of ice, which is 2100. But now at this point, ice is converted into water. So beyond this, let me call it point O, A, B, and C, D, and so on. So beyond from B to C, this ice is no more ice. This is liquid water. So I will use liquid C of liquid, which is equal to 4200, right? So remember this thing. At this point, boiling starts. At this point, C, boiling starts. So when boiling starts, temperature remains unchanged. Similarly, when melting was started, temperature was unchanged. So here liquid and gas together. So liquid just started boiling and then liquid ends up boiling, completed its boiling state, and now this all is your steam. So boiling point is here, and now you are having um, basically steam is heated, right? Or gas is heated over here, and here liquid was boiling. So this all is very comprehensive heating curve. What do we call it? Heating curve. Is it clear to you? ये ग्राफ पूछता है आप लोगों से. This graph is asked to you in your exam. I will show you some of the question and then it would be clear to you, right? Similarly, we have a cooling curve. This is cooling curve. Similar curve, exact same, but it is cooling. So cooling means you have gas. You are going to cool down the gas. Now some of the gas is converted into liquid. Some of them is liquid, still gas. So here all of the gas is converted into liquid. Then you are going to freeze the liquids, and then it becomes solid. Got it? So this is cooling
Yes.
curve. The previous one was heating curve, and this one is your cooling curve. So should I move to next?
Yes, sir.
Okay. Now we are calculating we are calculating heat capacity. Formula is given over here, but I have explained that at the top. Specific latent heat or specific latent heat of substance is defined as the amount of energy. The same thing again. That is equal to m times L, which is equal to thermal energy into is equals to mass into specific latent heat. So remember one thing, you are supposed to have mass into specific latent heat. If it is latent heat of fusion, it would be LF. If it is latent heat of vaporization, it is your LV. Okay. Specific heat capacity of ice is 2100 as I used at in your graph. Then specific heat capacity of water is 4200. As I told you, it's unit. It's
Sir, do we need to memorize these?
no need to memorize those. Right? They are given to you. Okay. So here is this is all C's. These are all L's. So latent heat of fusion of your uh, ice sorry, it is given, it is over here, right? This is that latent heat of fusion. Latent heat of fusion is 300 joules per gram, yeah, 300,000 joules per kg. It means this is very important to know that if I want to melt 1 kg ice, how much heat I required? 300,000 joules. How much? 300,000 joules. But if I want to boil 1 kg water, I need 20 sorry 2500,000 joules of energy. So this, it needs a lot of energy to boil 1 kg of water. So this is just for 1 kg, right? For 1 kg. This is also for 1 kg. Is it clear? Now you have some examples. An ice cream has a mass of 150 grams, so it is its mass. Its specific latent heat of fusion, specific latent heat of fusion, LF is 300 joules per gram because mass is given into gram. That's why the heat required to melt the ice. What to calculate? You have to calculate QF, which is equals to MLF. Okay, go ahead, calculate that. Your mass is 150 and LF is 300. So your answer will be 45000 joules per gram. This all is, sorry, simply joule, not joule per gram, because it is heat, so heat will be boiled into joules. Okay. Now let's talk about question number two. A heater which is supplying a heat at a constant rate of 1000 watt, completely immersed in 3 kg of block of ice at 0 degrees centigrade. The block of ice takes 1020 seconds to melt completely. Calculate the value of specific latent heat of fusion of the ice. So this question is actually very tricky question. It must be of 3 marks, right? So what is given? Power is given to you, mass is given to you, and time is given to you. So what to do? I told you that when power and time is given, you will replace Q with PT is equals to MLF. So you need to calculate LF. So LF is equals to PT divided by M.
Sir,
Yes.
it means that we're replacing QF with
Q.
PT.
Yes. QF with PT. Exactly. Right. So P is 1000. Time is 1020 seconds. And yeah, I can write that equation at the top. QF is equal to MLF. तो आपने QF को replace कर दिया PT से because heater power given है और time given है. And mass is how much? Mass is 3 kg. So just 3 ones are 3, 3 threes are 9, and this one. So this would be your answer, 340,000 joule per kg. This is its energy. Okay. So these type of questions will be asked to you. I have a request to you both. Take some time. Take a snapshot of this one. This 4, 5, and 6.
Okay.
Done. Mirab, yes. Done.
Yes, sir.
Okay. Then wait. I will figure out some other questions for you. Okay. The rest all are MCQs. Okay. So you have to do these two questions for me in just remaining 10 minutes, and then we will be done inshallah with this topic. Meanwhile, if I send you this file, will you be able to try these MCQs? If you get any query or any problem, you people can send me just tonight. But
Yeah,
पहले आप लोगों
okay.
ने ये दो क्वेश्चंस करने हैं, right? First solve these two questions and send it to me. Meanwhile, I'm
Sir,
going
कौन
to send you
से?
this file. So yes,
कौन से questions?
these two questions which I have asked you to take a screenshot. Yeah, these two. Three questions, sorry. This
Okay.
question number 4, 5, and 6 करने हैं आप लोगों ने, ठीक है?
Okay,
This
sir.
is your class assignment. Just solve it and send me at WhatsApp.
Okay.
Okay. And meanwhile,
Okay.
I'm going to send you this file, and please uh, go through these points. And if you have any query, don't get hesitate, send it back to me tonight so we can do this, complete it, because I don't want to spend more than a week on one section. So thermal will take because it is long. Okay. So please uh, go through these past paper questions, and then I will be back for worksheet solutions. Okay, ये वैसे मैंने worksheet के solution ही इसमें डाले हुए हैं. These all are the worksheet questions actually during my lecture. but unfortunately, because shortage of time, I cannot solve all of them in the class. So that's why I'm going to give you some of them as a homework. Okay, right, Mirab? Is it
Yeah,
fine?
okay.
Okay.
Yes, sir.
Okay. Yes. Let me check this one out. Okay. So see you inshallah in my next class. मुझे अगर कहीं if I need to have a class at weekends ना, so I will approach you people, and I hope that you people will be cooperating. But I will let you now be well in time, right? बिल्कुल in time नहीं बताऊंगा. I will let you know well in time, and then inshallah we will manage that.
Okay, sir.
Okay, see you inshallah.
Allah
Allah
Hafiz.
Hafiz. Allah Hafiz.